say there's a big ambition, small budget would be a reasonable summary. So the program was started halfway through the Shift to Rail program with a view to, in the end, providing a framework around the work that is being done in Shift to Rail and beyond, i.e. that there is a need for a sector-led view on the evolution of the system and a framework to evaluate proposed changes to that system. And I think what we'll see today is that there has been a lot of work achieved, but also this is the final event for LinX4Rail, but it is really still the beginning of the process to put in place the overall architecture for the railway system in Europe, and to give a process, a structure, a method to evaluate at European level the way in which the system can be changed and improved. So yeah, a big thanks to Pierre-Etienne, who's obviously worked very hard on this. I think also Pierre-Etienne and everyone in this room likes difficult, if not impossible, tasks. Rail is not renowned as an industry for being a place where people don't have opinions. People have lots of opinions on every single aspect of design. So when you are trying to look at a process from a European level, where we are talking about many, many dimensions and many moving parts, it's a very difficult process. Yeah, just to reiterate, I think LinX4Rail has been a successful project. It provides a good basis for the continuation of the work within Europe's rail, primarily through the system pillar, but also through the TT transversal project. I very much look forward to hearing everyone's input today. Thank you.
Thank you very much, Jan. So now we will let the floor to Thomas Joindeau to describe the SNCF motivation toward architecture.
Thank you. Hello, everybody. I will say a few words about our motivation from the SNCF point of view regarding architecture, and perhaps answering the question why we took this task of leading LinX4Rail, not only because we very like works with big motivations, low budget, but indeed it's very interesting. In a few words, why are we motivated by this task of system architecture? Well, the first thing, which is perhaps not the thing we all now have in mind, because we all now evaluate system architecture with very technical points of view, but the first interest of having a system architecture is just speaking the same language through the railway industry in Europe. I often have discussions with my colleagues from Germany, Great Britain, Belgium, etc. And it's very interesting that we speak a lot of things, interlockings, CCS, TMS, etc. And at the end of the day, often we don't know exactly what we are speaking of. When I speak about TMS systems, it is not exactly the same perimeter of what is considered as such system in other countries. So the very first objective of having a common architecture is having a common language in this Babel tower, which is the European railway. Having a common language for what for? In order to compare different solutions, different approaches we have in different countries, and also in order to establish common strategies for us towards our suppliers and towards all the rest of stakeholders in the European railway. So this is the first objectives, and the second one, of course, it's perhaps the objective of the system architecture now in this European level discussion. It's in order to lowering costs and delivering more through standardization of systems and products. And about that, I would make two remarks. I had even very recently discussions with some of you on those topics, so you won't be astonished by what I will say. The first remark is be careful with that because what is the level of harmonization and uniformization which is achievable and usable for our industry? The railway is not alone. There are other regulatory domains, labor rules, etc., things like that, which are not harmonized throughout Europe. So if we harmonize each piece of the technical part of the railway system, perhaps it will be very difficult because we will be in interaction with other things which are very, very difficult to harmonize. And second remark, it's great to harmonize and standardize, but we are not here only to make very bright technical things for clever engineers. We are here to offer transport services to passengers and freight shippers. So the question is, what is useful, what is interesting from a business perspective? And what was interesting with this LinX4Rail adventure is that the project, I think, succeeded in taking two interesting approaches. The first one is having a high-level, broad perspective approach of the system, so not going in the very technical details deeply in the system, but taking the broad approach. And second thing, giving a great focus on the business objectives, what is necessary for a business being, of course, money, environment, etc., all the objectives we all have for the railway in Europe, and taking those two very different approaches in the project. I think it was what was very interesting in LinX4Rail. Apart that, it gives, as you mentioned, Jan, I think very important inputs for the system pillars, and I think we all hope that all what we achieved within LinX4Rail will be of great interest and will be on the table, will be reused in the system pillar. Thank you.
Thank you very much, Thomas. So we will continue with the presentation by Pierre-Etienne of the objectives and organization of the LinX4Rail-1 and 2 projects.
Thank you, Gracien. Can I, for the following presentations where you have slides, I suggest the other presenters to do as I'm doing here, coming here to run the slide. It will be easier for you. So I think most of you know a lot about the project, but it was just a small recap. Refresh. Ça marche pas. Ah, pardon. Okay. So the objective of the LinX4Rail was to develop, as it was mentioned, a functional rail system architecture. And this architecture is not standing alone. It is supported by the Conceptual Data Model. I will not recall the history. You will just know better today what the Conceptual Data Model is now, and it is taken over by Emotional. But that established the standards for the interactions between subsystems, and in particular legacy and new systems which will be implemented. So in terms of organizations of both projects, there are 4 work packages. one on the architecture, which is work package 5 for LinX4Rail and work package 1 for LinX4Rail-2, and then 3 work packages on the CDM, one on the rail semantic dictionary, because as Thomas mentioned, the semantics and the to be able to name things in the same way is quite important in European framework. Then creating a CDM specification and formal definition, and you will see what is covered by this question of a CDM specification, and then having something that could really be applied. So 3 use cases in order to test and refine the definition of the CDMs that will be presented later by Fabrizio. And then I mentioned the architecture. So in terms of the work package structure for LinX4Rail, in part, apart from the management of the project, work packages 2 was developing the common data dictionary with semantics and ontologies. The CDM modeling itself was developed in the work package 3, and CDM demonstration was developed in work package 4. The CDM will be further developed and was further developed in the LinX4Rail-2, and the integration of the ongoing system architecture and development of the functional system architecture was work package 5 of LinX4Rail, which turns into work package 1, but this is just the subtleties of the projects for LinX4Rail-2. They will be presented in the globally in the project, so that comprehensively everything is presented in a coherent way. So this is for the very quick presentation of the project. I want to also here to take the opportunity to thank all the partners for their commitment. And sometimes it has been a bit difficult at the end of the projects to share between but although we managed some coordination and mutual complementarity between the system pillar groups and the LinX4Rail, but their involvement until the end of the project, because it has been quite an intricate work actually and you will see how LinX4Rail and namely LinX4Rail-2 feed task 1 of the system pillar. So thank you for being also with us in this project, and also thanks for the advisory board. I take the opportunity that we have one advisory board member today to thank also the advisory board, which give us very interesting scientific advice. So now I think it's time for the presentation of the results, and I will ask Pierre to come for the common data dictionary.
Thank you, Pierre-Etienne. So I'm Pierre Tan from UIC. I was the leader of the work package 2 since the mid of 21. And so we were tasked with the definition of a common data dictionary. So the idea was to define a conceptual dictionary that can be used and also is leveraging initiative and previous works. So the work initially around the CDM and that dictionary was to consider to build a federation of models. And so that we achieved, as we'll see in the following slides. And the visible result of that work, apart from the deliverables, is a web application available at the URL indicated on the screen. So when it comes to source models that came into this federation, so there was a bit of evolution over the time of the project, but eventually we have imported 6 source models, the ERA vocabulary, which is now in version 3.0, but which we have been importing since it's version 1.2.1 a long time ago. ULinX data prep, which is now in 1.2, IFC Rail for BIM-related matters, Rail system model, which is now in version 1.2e, Transmodel, which came later into the project, but was incorporated in particular to cater to the passenger aspect. And is the X2Rail4 model in its latest version available in LinX4Rail was from January 22. In terms of general features for the dictionary, we have the ability to import and export the models that are imported in the dictionary, and also to browse them. And finally, because those models are actually representing different facets of the rail system, we have a module to establish relations, semantic relations between models, and essentially facilitate over time the convergence between those models. So what does it look like? So it's a web application, the visible part. So with the source module, which can be configured, but here we're seeing the 6 main modules that have been imported. And the relations module that allows to establish and also search establish relations between concepts in the dictionary. Then when we are looking for a particular concept, we can search in the dictionary, and we can select the models we want to include as part of the search, and we have various features allowing to fine-tune the searching that we have enhanced over time. Then when it comes to browsing a particular source model, so what we've done is we have taken models that were not necessarily in ontology form, and we extracted an ontology from them. And so we have a unified tree browser that allows us to browse through these source models to see the structure of those models, but also access the various properties the objects have, and also the object documentation, as well as such facilities. Then when it comes to linking concepts, so we're essentially based on 2 browsers, we select what we want to link. Then we can qualify the semantic predicate we would put between concepts, and then eventually we can store it in the database, and that feeds into an ability to manage those relations over time. In particular, when people are trying to reach consensus on the nature of relation between concepts. So what we have devised is a simple 4-step process allowing to create relations, to put them in a forum, allow discussion there, and then to reflect the agreement that would be taken between experts back into OntoRail. Then after we can export the ontology form of these various models, and we also support a Sparkle endpoint, which allows querying of the dictionary through the Sparkle query language. It's quite similar to that extent in spirit with what is available, for example, on the ERA-RINF portal, the Sparkle querying. In recognition that users of the dictionary might come from a different background with different business interests, we also introduced later in the time of the project an ability to set user preferences, essentially to allow to filter the models that would be visible and also the version that would be visible to a given user. After that, we also did some effort, although it's still a work in progress. The documentation is always a work in progress, but we have a wiki to document the features of the OntoRail web application. And we also created an introductory video to the Railway Semantic Dictionary available on YouTube. From an architectural perspective, as I was saying, we have various source models. Most of them come in XMI because they are UML models, but one of them is directly an ontology, which is the ERA vocabulary. And so we extract, when it's not an ontology, we extract an ontology from these XMIs, and then we load them into a graph database, OntoRail GraphDB graph database. And then we have web applications to query or modify this graph. Looking forward, we had investigated on the border of our scope several aspects, and I'm gonna talk through it a bit after in this today. But we notably looked at the question of serialization related to the data exchange format. So what we had looked was to do a project and platform independent representation of data, so RDF based on the RDF serialization. But we also, through collaboration with other Shift2Rail projects, we were introduced to the Chimera framework, which is a composable semantic transformation pipeline, which we have looked at. And ultimately, this initial investigation conducted in LinX4Rail will be followed up in FP1 Motional, as I will detail later. Second thing is we had the LinX4Rail focus was mainly on the conceptual layer when it comes to work package 2. But we had identified in the deliverable 2.1 the potential for a lexical layer on top of the conceptual layer. And interestingly, this popped up as something that would be useful to solve some of the questions raised in the ERGU system pillar around the glossary for the rail. So we'll be leveraging that going forward. We also investigated the links between the conceptual data model and the architecture, and that as well is popping up in discussion in system pillar and FP1 motional. The idea being that you can annotate architecture elements with semantic annotations, notably to prevent ambiguity about logical component that would be developed in parallel projects. Additionally, when it comes to having an ontology, we needed to have a way to unambiguously designate element of that ontology. So we had introduced preliminary form of this IRI scheme, but now this is being followed up in FP1 motional, as I will document later. And finally, because it's a federation of models, the models that are part of this federation evolve over time on their own because they have their own life cycle and their own governance. And we had identified that we needed a way to track what would be the differences between those model versions, because it's not necessarily something that model owners actually do extensively. And so we'll see later in this session how we tackled that, and that has been followed up in FP1 motional. And one last point about the dictionary and in general related to this federation model was the stress that was put within LinX4Rail on having open licenses in order to freely be able to use the concepts that are part of the dictionary, and also the importance of implementing semantic annotation wherever possible in order to resolve ambiguities between different models.
Thank you very much, Pierre. And now we will switch to the CDM work package presentation by Craig Taylor.
Hello, everybody. My name is Craig Taylor from Alstom. So in work package 3 for LinX4Rail-1, and I was involved in work package 2 for LinX4Rail-2. And here we worked in specifying and creating a CDM which could serve the needs of demonstrators. The demonstrator part of the project was in work package 4, but in work package 3, we provided the link between the ontologies and the implementations to serve and prove the applicability and the usefulness of the CDM by validating them from demonstrators. Some of the objectives that we had, I won't go through all of them, but I will pick out some. Common modeling design rules and patterns for global consistency by analyzing and looking at the different domains that the source models represent and applying them to the needs of what would be the demonstrators that were used to validate the results. We had to define common modeling rules and designs and patterns. Analysis of candidate tools for import and export. That was an analysis activity that we had to cover. The major part of creating a link between source models and providing and serving the needs of demonstrators, and in the future what will be applications in the railway industry, was done by defining a framework which consisted of the different elements that were needed in order to come from a data model and in the end to serve an application in the railway domain. The word federated models and federations is used quite a lot in these projects, and it is the concept of having individual source models, and instead of I mean, one way of combining the data from different source models is to either say we can have a dominion, that is to say, a one central common entity controls the data that is coming in from the different domains that are used in the railway industry. The other is to say it's a federation where the different source models are agree to common rules and common framework that will be included in a federation. Thereby, they have their own integrity, their own existence, and exist in their own under their own rules. Yet they are included in a federation, and that is the framework that we created in Work Package 3. So the work that was important. Performed once this federation, the idea of the federation was conceived and put into place. RSM, LinX4Rail 4, LinX. So that's the list of models that were imported. In the initial description of the project, there was also the aspect of including an additional. This is for LinX4Rail-1, an additional source model, which was RailML. Under the course of the analysis, there were certain issues that came to light which made it unsuitable to be implemented at that time or within the realms of this project. Model evolution, task 3.2. So the CDM specification. So the results of this task would be a document which would define the specification of the CDM. This was completed slightly late. It was reviewed, submitted. It is currently we have review comments which we are undergoing updates to the document to be resubmitted. We had 2 milestones to complete. There were preliminary inputs on CDM user cases for Work Package 4, and that document formed the basis of the inputs from our project into Work Package 4, which was the actual realization of the demonstrators to prove concepts and the CDM. This was the timeline. On the top part is LinX4Rail-1, on the bottom part is LinX4Rail-2. And as you can see, there is quite a lot of interaction between the two projects. So the top part, LinX4Rail-1, is creating or defining a CDM together with, as Piatana said, described before, the ontologies, and linking those to proving the CDM by demonstrators in Work Package 4. Some of those documents then fed into LinX4Rail-2, and in LinX4Rail-2, we used that to prove that the CDM that we had defined was extensible, that it could be expanded with additional data source models. If you look at the top left-hand corners, we show the representation what is represented there are the source models, a part of the federation, the export, which was part of the scope of Work Package 2, which extracts the ontologies into a platform-independent model, which Piatana described earlier in his presentation, and those are available as a semantic dictionary on the OntoRail website, which is the little picture above that. Due to the limitations in time that Work Package 3 experienced, we had to deliver a CDM to the demonstrators. And if you look at the bottom, the left-hand corner, that is the data that was needed to be provided to the demonstrators. And remember, from what I said before, that demonstrators were the proof of the CDM concept from the different railway domain models. The data that was taken in order to produce a platform-specific model to fulfill the needs of the demonstrators was then added as a manual extension, and creating from the PSM databases through different tools and programming languages in order to provide data for the individual demonstrators. One could say that this is the platform-specific part of this. Looking in a future vision, maybe would not be, it could be improved. One could say that the platform-independent model could reach a sufficient richness in its ability to describe data that a platform-specific model at this level would not be necessary. But this is what we needed to do in order to fulfill the requirements of Work Package 4 in order to be able to build demonstrators. So these are the objectives and the status. I wanted to just show this. There were certain delays in the project, which led to certain aspects of the project. We could not explore them as thoroughly as we would have liked to. So as far as the objectives that were achieved, I would say we have achieved all the objectives. Regarding the promotion of CDM by interoperability and interface to other initiatives, I would say there we could have done more work, but due to the delays that we experienced, we couldn't do that to the extent that we would have liked to. So going on to LinX4Rail-2, once we had a CDM, LinX4Rail-2's objectives were to prove that the CDM was expandable in order to take into the account the needs of different data models. There were certain requirements on the project, setting up bilateral collaborations, for example, with ERA and the Joint Sector Group, TAP and TAF, in order to prove the expandability of the CDM and to take account into what current initiatives are being undertaken, and to identify how and what benefits can be gained from the developed CDM and its applications in new domains. There were two tasks. Actually, there were three tasks. It's on the next slide as well. Each one producing a deliverable. Task 2.1 was to analyze and define updates to the ontology. And this we have done. We have used a project called Extensive as an example for demonstrating the extensibility and adaptability of the CDM. Then we have actually implementing. Task 2.1 implemented the extensions to the ontology. Task 2.2 implemented the extensions to the actual CDM. And task 2.3, it was technical dissemination, where we had regular reports coming from the project, bi-monthly presentations, disseminations. We had quarterly workshops. We had both advisory board meetings with academia and quarterly workshops where we described what we were doing, what our plans were with members of the industry. And we did ad hoc on-demand workshops where it was where we were requested from people in industry. So as a conclusion, The dissemination work was the webinars, regular meetings, advisory board meetings, to prove the extensibility of the CDM, both in terms of ontology and in terms of CDM. We had extensive meetings with the extensive project. And the deliverables, D2.1, which is the ontology update, preliminary, D2.2, final update, D2.3, which is the specification of the extensions, were submitted, are currently being returned to us and are undergoing updates. Some of the collaborations that we were intending to have with certain projects, such as condition-based monitoring from Connector 3, Freight4Rail, we didn't get the opportunity to explore to the detail or that we had actually wanted to, but the work has been initiated, and we are discussing how the handover will continue in the Europe's Rail projects in FP1. So as conclusions, CDM, we consider the CDM can meet the initial user cases that were defined in LinX4Rail-1. That is by creating a framework which was consisting of a federation of the source models. It can be extended, as we have shown in LinX4Rail-2. Ontologies and the CDM provide a framework, and we are currently in discussion with FP1, as to how we perform a handover to continue the work. We provided a CDM for the demonstrators in the project so that they could show and demonstrate that the CDM provided the needs that the demonstrators had. Dissemination work through academia, social media, and social media and meetings and workshops. Looking forward, in FP1 or Europe's Rail, we have to look at what will be needed for CDM to be gain further deployment within the rail industry that gives a real business value to the people who want to use it. And in order to get there, we need to look at governance, which has already been started in a preliminary stage. These projects, we need to look at data integrity. When data is taken from source model, guaranteeing that that data model is still intact when it actually reaches an end user. Validation. If we look at data being used in vital railway applications, as it is today, there are processes in place to ensure the integrity of that data. Some kind of method in order to meet that, if the data is to be used in a vital application, also has to be put into place. And publication of the CDM is a fundamental and essential factor for the success of CDM, and that is something we are currently looking at and trying to implement. Okay, thank you.
Thank you, Clectay. And now we give the floor to Fabrizio for implementation. Oh, you have a question, yeah? Yeah, sorry. Yeah, sure.
Actually, 3 questions. Federated models, well, federations in general, they still have rules. So possible just to briefly describe within the consolidated CDM structure what the rules are. And then looking forward, you see, I guess, well, first of all, where do you see the main use cases and what do you see as the next models to import and incorporate?
That was only 2 questions.
Well, the second one had 2 bits.
Yeah, the federation. I mean, the rules of the federation at the current state of maturity in the concept are basically that these data source models are willing to be participants in the federation, and they provide and work together with us to create the tools that are needed to extract the ontologies from the data source models. So it's at that level. And as a method, a vehicle in order to move towards a consolidated dictionary for the railway domain, it is, in my opinion, and I think what we have showed in the project, the best way to go forward, rather than at this stage of the railway industry. And when one talks about the railway industry, you can say we're not talking tens of years, we're talking 20 years, 30 years, 40 years. Maybe looking forward, that would be there are better and different ways to do things. But at this stage, the federation is the best way to proceed. Your second question, sorry, could you repeat it?
Yes. So, where do you see the use cases in the next in the next stages, and which are the next models to bring into the federation?
There are already identified certain areas, condition-based monitoring to be one, freight for rail, another one. But within the part of the work that we'll be doing at Europe's Rail is that people from the industry themselves come up with applications to be used, and then we do FP1 will do the work to analyze and to consider if it's a valuable addition to be considered. So there's like ATO possible additions. There are sensors, more detailed level of data collection items that systems that could also be included. So there are several already identified, and more will be identified in FP1, but those are a couple of examples.
If I may add, just before Fabrizio, who will show also some examples, the use cases are more generally all the interfaces between the subsystems. When you replace either a subsystem and you want to still maintain it connected to a traffic management system to a CCS system, when you have the proprietary interfaces, it's a huge cost to replace these interfaces. Even if the core is standard, it's a huge cost and for the community at the end of the day. So it would be a great benefit that progressively all the sector adopts the CDM in the interfaces between the subsystems, so that between the main subsystem and even inside to some extent, in order to manage the transitions between and the implementation of new systems or new or innovative features in subsystems. Even in CCS, inside CCS, you could use the CDM not to have proprietary languages.
If I may just add something, so indeed, I will discuss briefly about it later, but so in FA1, we already have had discussion with several of the FAs, and we see people asking, for example, for an ability to describe the yards, something that's currently not covered. They are looking also at extending the TAF-TAP. So that we'll see what comes out of it, but the process is they identify what they think is missing, and then they tell us, and then we see how we can incorporate. There are things related to also the description of a train itself. Actually, in some of the FAs, there are models being created to describe the train. And once this becomes more mature, I think that would be a good candidate indeed to extend the CDM on those aspects as well. So the good news is that I think the legalities aside of inter-FA communication, which is a bit complicated at the moment, but if we put that aside and we'll fix that eventually, I think the system works because the transversal nature of FA1 is actually already at play.
There are no questions. We may have a session of questions afterwards, but I will give the floor to Fabrizio for the work package 4, the CDM demonstrations.
Hello, I'm Fabrizio Cosso from Hitachi. I was the work package leader for the work package 4 that deals with the CDM demonstrator. The objective of this work package were essentially two. The first one was to prove the applicability of the CDM solution studied in work package 2 and work package 3. To define some indicators that could be used to prove the goodness of the solution, and to apply these indicators to evaluate these indicators against 3 different demonstrators coming from 3 different use cases where with use case with and some application scenarios in real application scenarios. The structure of the work package to obtain these 3 objectives was split in 5 different tasks. The first one was the KPI definition, 3 tasks for each use case, and the final task was the review and return on experience. So mainly the calculating the conclusion and the KPIs defined previously. The process that we followed in the work package to obtain the results for the project was the one shown in this slide. So the KPI definition, then to provide a clear description of what we want to achieve in the demonstrator. Let's say essential to understand which are the data that we need to exchange between the systems and which data we need inside the CDM in order to ask for modification, for extensions, or for addition to the existing CDM. Then there was the use case gap analysis, is the phase, but I will explain it later. CDM extension, if needed, CDM update availability, use case implementation, use case testing, and KPI evaluation. Now let's see these steps one for one, starting from the first 2. So KPIs that were defined for the work package were essentially of 2 kinds. Some of them were quantitative, some of them were qualitative. So for some of them, we had metrics and exact, they could be evaluated with numbers. Some other, for example, the coverage of the use case requirements and is an example of quantitative KPI. Some others, for example, the development costs or performances could be evaluated in a qualitative way, so with some metrics like bad, medium, good, which was evaluated in the end of the project. The 3 use cases, the first use case of the 3 dealt with the ATO systems. It was split in 2 different scenarios. The first one, CDM to configure an ATO over ATCS system. And the second was more focused on static data like topology information and planned timetable information coming from a traffic management system, and wanted to demonstrate that CDM could be used to import data, configuration data for ATO trackside and ATO onboard application. And the second one was more dynamic. So in the it aim at demonstrate that the CDM could be used to exchange data between a TMS, operational TMS, and ATO trackside. Then there was the second use case was energy management scenario. So we had in SNCF proposed to prove the applicability of the CDM for data exchange between two simulation systems, the OSRD and the Esmeralda system, where the OSRD was a tool to design and perform operational study for timetable calculation, predictions of delays, and so on. And the Esmeralda is simulation software which aims at calculating an efficient energy consumption. So exchanging data between Esmeralda and OSRD may obtain an efficient energy management utilization. And the scope was to use the CDM to exchange data between these two systems. The third use case was a use case coming from another Shift2Rail project, which was into Smart 2, where we had different intelligent asset management system, each one focused on the different aspects of the management, and the objective was to show the results of the three different intelligent access management system on one integrated HMI. So the objective was to collect data from the different systems into one using the CDM. So as we can see, the three use cases were different also in the application context: maintenance, energy consumption, and ATO. So once we had the demonstration, the description of the three demonstrators, we proceeded with the gap analysis. So what is the gap analysis? Gap analysis means we described which data were needed for each use case. We have the CDM. Let's see what the CDM contains and challenge the content of the CDM. If something is missing, so we have the requirement list and we perform the gap analysis using the CDM that Claik previously described. If we identify some gap, during the project, we asked to WP3 to extend the CDM in order to complete our demonstration implementation. For the time being, it was a manual extension of the PSM. The process in the future may be improved in order to provide some mechanism to extend the CDM. This was the results at the end of the gap analysis. It is not the results at the end of the project, but as you can see, the first use cases that were mainly related to the railway domain were covered quite well, while the last use case, the maintenance use case, which has some special field related to observation and measurements, was not covered inside the PSM. But fortunately, the rail system model, which was one of the federated models in the CDM, already had an observation and measurement domain. So we just needed to ask to the PSM WP3 to include also that part in the CDM. So the unhappy faces became happy at the end of the project. So this is the part. So the CDM extension was already described. Let's see how I already described this, but from the CDM short-term solution, we performed the preliminary KPI evaluation gap analysis. Then we asked for the extension, and from that we obtained the PSM in JSON. We applied the transformation in XSDs and JSON schemas to be used for the implementations. And we used them in the APIs to concretely obtain the messages to be exchanged. So this is the implementation schema of the first use case, where we developed two converters, one from the source ULinX topology schema to the CDM, and one from the proprietary data, timetables, and so on of the data source owner into the CDM. On the right side of the schema, there is another converter that was used to convert the CDM into the proprietary format of the system that of the heterotrek side system. This is more or less the same schema that we had also for the dynamic operational TMS data exchange using the CDM. Okay. This is another example. This is the practical output of the CDM application. So in the PSM, we had a class diagram representation of the objects. On the right side, the class diagram described in UML-like definition. And on the right side, on the left side, there is the JSON that concretely JSON file that concretely contains the data that has been exchanged between the system. This is another example for what concern timetable data. For the second use case, the matter was a little bit different because in this case, the original data model, the proprietary data model, was already similar, was already derived from the rail system model. So in this case, there was no need to create converters because it was already, it could already make use of the CDM as it was, more or less, especially for the topology and for the infrastructure part. This is the implementation schema of the last use case, where we developed a converter. In this case, differently from the previous one, we made use of the XSDs instead of JSON schema. So this to demonstrate that the CDM may be used in different serialization formats, even if the origin model is the same. We performed different test cases, one for each intelligent asset management system that dealt anomaly detection, track maintenance, track circuit data. So there were different scenarios and different assets to be to collect data from. Also for these use cases, I put some example of what the translation between CDM and serialization messages mean. Again, we have on the right side the class diagrams coming from the PSM of WP3. and on the left side, the concrete message that was generated coming from that class diagram. These were the messages that were exchanged across the system during the demonstration. Last step, KPI evaluation. So demonstrator, description, implementation, evaluation of KPI to prove the goodness of the solution. The table as it is doesn't mean so much, but if you analyze it with patience, you can see that there are the KPIs evaluated are pretty good, especially for what concern domain and entities contained in the model. There was a good coverage. Where we have lower indicators is the field, the attributes, the fields more detailed in the entities that may differ between scenarios and may differ and may come more depending on the practical use case. They may differ, and many other attributes, I assume, will be asked as soon as more use case will come. We can also see that the implementation efforts are not so much, and the extensibility was good. The complexity was not high. The documentation of the CDM that was a wiki is between medium and good, because some domain were mature and some other were less mature, but could be improved in the process of growing the CDM. Conclusions. The CDM contains enough modeled information to cover data for the use cases. The structure of the use case of the CDM is easy to be understood by people that used it. CDM was compatible with some other existing models, LinX model, also because LinX is part of the federation, but it was proved that the translation between the two was quite easy. It could be used, it can be used with different platform and programming language, because we used Java, Python for the programming, and we used JSON and XML for data exchange. One thing that can be maybe proved to simplify the effort of the implementation is to prove to enrich the documentation with real examples for the newcomers in the CDM world. Okay. Suggestion for improvement. It will be very important to define a governance process, because as we said previously, new use cases will come asking for new models or new fields, entities, and so on. And it will be important to proceed with a governance that allows to do the extension of the CDM in an organized way. The second point is left to future work to explore the possibility of experimenting the ontological approach. The work package ended 1 year ago, so this is something that is already happening in emotional and the other system pillar activities. So this was a suggestion, now is the real fact. Okay, I completed maybe with some delay, but thanks for your attention.
Not so much. Thank you, Fabrizio. Maybe we have one question from Jan.
I do actually have one question. On the go ahead. Sorry. The TMS use case that you described, what's the relevance of the applicability of that to the current approaches, for example, in RNE, and has there been discussion in terms of use of this approach within what RNE is doing?
I assume no for the moment, or at least no at the moment of implementing the CDM, because it started 3 years ago and ended last year. So I think no at the moment, but this is something that TMS and the ATO especially are use cases that are currently under investigation in EuropeRail and so. So I think that this is something that will be explored in the next steps of our activity.
Any other question? Because we may have 5 minutes and then we'll take the break. Martin, yes, and Johannes after.
Just one question. If I understood you right, Common Data Model doesn't consider about shunting operations, or did I get it wrong?
Sorry, about?
The shunting operations, so shunting in yard.
No, in the 3 use cases that we had, there was no shunting operation. But
if I may follow up on this, so indeed that's some things that's not there yet, and FA5, or at least one of the work package within FA5 is very interested in that, and we're from a emotional perspective, not from a LinX4Rail perspective, we're already in contact with FA5 on those matters. So it's not there yet, but it will be coming eventually.
Then we have a question from Johannes. Yeah.
Yeah, just one question. Is there a document available describing the details of these use cases? Because I would, for example, be quite interested in which detailed data in the data model are referred to breaking in the ATO use case.
yes, there were 2 deliverables, D4.1 and D4.2. D4.1 contain detail about the description of the use cases. D4.2 contains more detail about the implementation. So, yes.
Are they publicly available on the LinX4Rail website?
D4.2 is public. D4.1 is internal.
I'll have a look to 4.1, 4.2, and they come back.
If there are no further questions, I said, yes, Peter.
I have a question regarding both presentations we have had now. In a sense, we have been working in 2 parallel tracks because of time limits, as you mentioned. And so it's a little bit confusing sometimes to see the differences and how they are connected. And you have pointed out that in the work that will come in the next steps, and so it will be somehow merged. But how far are those ideas come so far? I mean, we don't want to have 2 different CDMs. I think it's an important question for us to see in the future steps here.
Yeah, I think it's a very good question. Thank you, Peter. Actually, it's more converging than it looks to the extent that even within Linux4Rail, there were links inside the ESM model with references to the PEPIM model, so the platform and project independent model. So the seeds are there. The systemicity of it is okay. It's more of a start of a garden. It's not a complete field. It's for sure. Second thing to note, and that I will talk a bit about future session today. We are also looking. So I think what we recognize from the discussion with several stakeholders is that some are looking at making models that are really specific to their use case, and some are looking at more platform and especially project independent representation of data. They're not the same stream, and to that extent, I think it's not that there is multiple CDMs, but there are more than one way to represent the same thing. As long as we are able to link something that is expressed in a platform and project independent way with the platform specific and project specific way, and we have, I would say, good leads towards that, I think we should be fine. One of the things we are looking, and I will talk about it briefly, is around conversion between platform-specific representation and essentially a platform and project independent representation. So we have activities in motion to that extent. So, for sure, right? It looks parallel. I think it's converging, but yeah, it's not entirely hyper connected at this stage. It's a fair comment.
I think to sum up also the ontology is a very good approach to find the common communality between what may look like different approaches also. So, I think we don't have so much. We are a little bit over time. So I suggest if you have further questions, you ask them directly during the coffee break. And I suggest we have a quarter of an hour coffee break, and then we resume with the architecture. Thank you. Okay, if we can resume, please. Sorry to interrupt your interesting discussions, but we have the main course on architecture, if I may say, before lunch. Okay. So it was freezing here. Yes, but here is now it's hot. I don't know what air conditioning is. It was freezing because and now it's hot.
Air conditioning jump.
Air conditioning is not modulated. Okay. So it will be a free voice presentation about architecture. Vladislav from DB, Marcus and myself will present the different not very separated, but the aspects of the architecture. So just in order to set the stage, the general objective of this work package 5 in LinX4Rail and work package 1 in LinX4Rail-2 was to develop a high-level architecture for the railway system, which was expected to be modular, to be open, and to enable faster changes and technological evolution and implementation in faster implementation of innovation in the railway system. So that's very much in the objectives of as it was prefigurating the system pillar. So now I will give the floor to Vladislav for the presentation of the main work packages.
Thanks, Pietian. Hello, hope you got all a good break. I'm presenting today the German railway, and I need to say that I jumped really at the late stage. It's a project, and because a colleague of DB left the company, and I took it over within my 10 other projects where I'm involved. But anyway, it was a pleasure to work with Pietian, to work with Cassian, and thanks for your support again. And I will give now a short update on overview where we was with VP5 at LinX4Rail-1 and VP1 at LinX4Rail-2. So we started with VP5 to get the input analysis, starting with RSC and Acora. We try to get interface with the system or technical work package of the other shift-to-rail projects. It was really the core to get other shift-to-rail projects involved for analysis of specifications and requests. We're sending recommendations based on the technical assessment, including NPICs to the program board, and then reporting about the integration decision by program board and the forced implementation. Then we go over to the VP1. It was like an extension of VP5, where we propose the impact analysis to the program board based on the selected architectural elements. And we started as well here with RCE and Acora. As well, the second point, we enhance evolution and method and quality of functional modeling methodology provided by Shift2Rail projects. And all activities outside from Shift2Rail, for example, ULinks for integration ability into the rail system architecture. And what we have done as well, we considered for selected areas and fully formal modeling for populating the functional railway system architecture. I will hand over again to Pietian and make at the end the conclusion.
Okay, I will go deeper in the architecture work that was developed in LinX4Rail, and you forgive me if we borrowed some figures from the system pillar, but that in order to show the coherence between the both approaches. So what we are dealing with in LinX4Rail, it's high level, and it's equivalent. I'll come back to it again, to the task 1 of the railway system pillar. So the rail system as a whole and its connection with the other transport modes, and then you can find also the link with the CDM. For example, if you address transmodal is fitted to the relationship between the railway transport and the other sources of transport. And what is to be kept is that here we are a rather high level, and we are not getting into the subsystems. Another point to have in view in terms of architecting work is that the main purpose of the architecture is not to develop architecture for itself, but to facilitate the transformation of the system and integration of new technologies. And so from the current state to a target state, there will be a number of intermediate stages for which the evolutions of the architecture would have to be managed. So an important point and this is what we insisted on in LinX4Rail, and Christian also insisted on that. What we have spent most of our time to do is to describe the current system, the as-is system, because if you don't know where you are starting from, you don't, and you just want to go somewhere, but you don't know the how much it will cost and what the practical steps you have to carry out to go to the your desired stage. So this is to underline the importance of having the as-is system described here. So the methodology we used is that to describe the as-is architecture, as we mentioned, to have also the scope and the objectives of the broad scope of the objective of the target systems, and then we built the as-is system. I will come back to it later to some use cases and scenarios, and we hope that with the adding up scenarios from the time going on, there will be completing the view on the architecture. And in order to identify what has to be changed into the current system, we had, this is the point 2B here, we had the interviews of the of EURail JU key actors of the project and key actors of EURail, in order to identify these pain points in the current system and what could be changed. I will come back to detail. And then this is the first step that is, you will see it, that was LinX4Rail-1, and LinX4Rail-2 as combined with the task 1 of the system pillar, will continue developing the to-be views of the enterprise system and the high-level requirements for the the future system. And in particular, if you are staying this afternoon, you will have the opportunity to provide your input. I'm advertising for all of you into the architecture workshop we will have this afternoon based on the to-be system. This is the. So in terms of high-level objectives, we started. You had the EURail work program high-level objectives. There was the system pillar common business objectives, which were made from different inputs, including some the common business objectives that were developed from LinX4Rail, and Marcus will develop that later. And so these are the main high-level objectives of the target architecture. So improve performance, reduce cost, as it was already mentioned, a sustainable and resilient transport, harmonized approach to evolution and adaptability, and speed of implementation. So a first view of the as-is architecture that was developed may be familiar to a number of between you. What has to be understood is that it's organized in layers here. And you could see 1, 2, 3, 4, 5, 6. You could have 5 or 6 layers, starting from the upper layer, which is the company management layers, getting into here more they manage the processing the transport, then going deeper, managing the railway system, and going also deeper in the layers, getting into the on the top, you have the strategic organization of transport for passenger and freight. Then you get into the traffic management at higher level. You get deeper into the lower level traffic control and other subsystem, and also energy management. And then you have the physical or assets or the IT assets or even the people here who are doing without and a lower level the monitoring layer. So you could see that we had this organization with the external stakeholders around. Basically, we worked on 2 use cases in LinX4Rail, LinX4Rail-2. I will show later on a little bit more use cases based on energy management, which are combined with the system pillar task 1. But basically, we have a freight train going from Rotterdam to Genoa in freight corridor, and also a high speed trip from Paris to Berlin in order to be interoperable and in order to combine high speed and conventional line. So from this, from this description, high-level description of the railway system and the use case, from the interviews I mentioned, we derived at very high level again some evolutions for the railway system. And all the mentioned items, and you will find them in the reports developed as verbatims, which were identified by the interviewees, were clustered into five main subjects: improve user experience with the related evolutions, augment capacity and automation, improve transportation offer, tackle operational and technical diversity while remaining cost-effective, and also developing the architecture and system pillar. For each of these points, A1 to 4, C1 to 5, B, and D, for example, for the cluster B, we identified the involved subsystems which were impacted by each of the improvements that were identified from the interviews. So you could see where the improvements from these interviews should be soaked into the in the subsystems. Another example is how to augment capacity and automation. You can augment capacity by automatic train operation, and then you can see that this is the violet purple perimeter which is impacted. There was also the capacity and automation, automatic translation that was identified, or harmonized HMIs, human-machine interfaces, and you could see also the train system which is impacted here, extending rolling stock fleet, extending network. You could see also what is impacted into the. From this high level requirements, there was also from the interviews identified some lower level requirements that could be allocated to various parts of the such system. So we have from the LinX4Rail interviews some elements that can be used in terms of specifying more precise requirements to the subsystems. So finally, what we did, and which is in the report of the LinX4Rail third release, is the as-is architecture and the interviews and the clustering of pain points, and what remains to be done and in LinX4Rail-2 and in the system pillar. And you can see on the right-hand side the work that is feeding also the system pillar, getting into more and revisiting the system perimeter for task 1, and also having the requirement analysis of the as-is system for 1 and 2 defined on a further set of use cases, and also enabled to define the transition to the improved system. So the process which was carried out now in LinX4Rail-2 in coordination with task 1 of the system pillar is revisit what was done in LinX4Rail and capture the complete railway system environment and stakeholders, identify use case and refine the CBO into performance, So then identify key performance parameters and then to derive performance requirements towards other tasks. So where are we now? We have been revisiting the environment and stakeholders. We identified in their precise activities and rules and putting them into the mapping them into the railway system, as you will see here. For example, for railways and statings and infrastructure managers, we have defined generic subsystems in the railway and the stating organization, the train operators, safety management system, strategic management. And for each of these entities, we have identified some activities that will be later connected to the system analysis. The same for the infrastructure manager. We have, for example, energy management system, monitoring system, the traffic manager, commercial services, and infrastructure designer, and station manager with some activities. And these activities are then matched in the as-is railway systems subsystems. So you can find any of the organization sub activities and sub organizations mapped into the as-is system here, in order to verify that our mapping of the railway system was also coherent with the activities of the organizations we have now in Europe. Of course, we didn't do it completely. We have here for the operate system railway system layer. We have it here for the control and command system layer, and for the managed physical infrastructure layer, it is a starting work, but it shows how these activity match the subsystems and monitor and maintain railway system. So in the alignment between LinX4Rail and system pillar, I said that we are consolidating the as-is operational analysis and consolidating the as-is operational capabilities and refinement of this as-is operational capabilities to map in LinX4Rail analysis into the as-is operational system, and then developing the to-be operational system analysis and development. So the operational analysis development and the system analysis that will form the to-be development. And in terms of roadmap, you could see from what the current status is in terms of analysis of the as-is systems. In red, you have the workshops, which are the LinX4Rail workshops, and in purple, you have the workshops, which are the system pillar workshops in terms of roadmap. And you can see that they are still given the development we have in and you will have in the system pillar, given the developments, there are still activities to be mapped, but the state of play of the different activities within this transition, the short-term roadmap, are identified and carefully monitored. A few more elements, because as I mentioned, we didn't just stick to the I would say initial LinX4Rail grant agreement, even if we are completing our grant agreement as required. We also incorporated some of the method and tools of the system pillar, and namely the Arcadia Capella methodology, which was already discussed in LinX4Rail, and the proposal to adopt it in for the system pillar actually comes from the discussions that were already taking place, among other, in the LinX4Rail method and tools group. But we are mapping how we can manage electrical energy with a description of the activities in the subsystems matched into the Arcadia Capella formalism. We did the same thing for manage and monitor infrastructure with these descriptions, and also manage capacitive planning. So in terms of the LinX4Rail models, system models, they can be easily turned into the capillary modeling, and then the activities, which are the main activities, like electrical energies and operations manage and monitor infrastructures and capacity planning. Operational activities can be matched to the subsystem description, which is which was developed in LinX4Rail and easily mapped into the Capella model. It can be transferred to the system pillar. So the outcomes, first outcome, and I will add the other one. Oh, sorry.
Yes. Oh, no. So let's conclude. We can conclude that there has been a great and big work has been done on the architecture. So we was really in close contact with all relevant Shift-Rail projects, especially the IP2, and by participating in the VP2 meeting. Apart from the Shift-Rail projects, we was also outside from Shift-Rail, as I mentioned before. We was active in LinX, we was active in RSC, RCI, Acora, and experts from selected call for tenders for railway undertakings. I was participating at the task 5.3 meetings, explaining the works and tasks. Apart from this, the work has been done based on the inputs from projects inside Shift-Rail, which was dealing with system architecture, so LinX4Rail-1, VP5, ATO, so X2Rail projects, Tauro, and development of the perception systems, OpenCore, Smart, and Smart2, so IP5. And as well the connector 1 to 3 work on TCMS. And what has been mentioned already several times, all relevant input has been shifted now to system pillar, and we will still work on it in course of the system pillar ramp up phase accomplished with September 22.
And so the outcomes, the general outcomes of the both projects in terms of architecture is that a global architecture of the ASIS system, railway system, was produced, as well as the pain point identification and the macro solution allocation to subsystems. And as for LinX4Rail-2, the coordination with Simpila involved revisiting the architecture and role of the stakeholders, revisiting and consolidating the operational use cases using the Arcadia Capella formalism, and paving the way into requirements for the system to be. That's it. I don't know if you have some questions. We will have also a focus by Marcus on the CBO related tasks, but if you have questions over architecture, we may have 5 minutes for questions. If everything is clear, we go to the CBO. Okay,
thank you so much.
So yes, the CBO have been mentioned a number of times. Maybe my title here is a bit focusing too much on the second part of the slides I present. But first of all, of course, architecture is not our polar. It's there to serve some objectives, and it was one of the first important things, excuse me, to identify, and it had its own work package 5.1 or task 5.1 in work package 5 to identify what the common business objectives are in the railway system, and so this was the first major contribution there. And obviously, there needed to be a link afterwards from the business objectives to the actual architecture. The common business objectives have been derived by essentially a small team of authors that then reflected them within the sector by quite a large a group of people and prominent people. I think of the original authors, Ralph is here in the room. I don't know why. I don't think you're the only one of the original authors, but anyway. So thing is, it was obvious that there are legitimate objectives that are particular to certain stakeholders in the system, and there are objectives that are really shared by everybody in the railway system. So this was the first important distinction. You can see this in this small table. You don't need to read it, but at the left-hand side, the first 3 sections show the business objectives that are specific to individual stakeholders, and the lower ones then they show objectives that are important to all the stakeholders. So this was the first initial work. The numbers are given in the right-hand side on the slide. Bottom line was there was about what is it, 15 plus 25, 40 common business objectives. The common ones had been grouped in 4 categories, and the work was finalized in April 2021. And the question was how to relate this to the architecture. This was done the interesting next part, and it all started with the system pillar coming into play when it was realized that LinX4Rail common business objectives need to be adapted to the other reference frame of ERJU and SARA, and in particular relate to the impacts identified in the EU Rail Master Plan. So that's the 7 high-level objectives that Pierre-Etienne showed in his slide. So there was then massive rewriting to transform the LinX4Rail's common business objectives into system pillars, system objectives, and this finally ended in a document where there were 3 structures, three layers of hierarchy, so to say. It was starting from the 7 impacts of the EU Master Plan, broken down into about 30 topical groups and ending in 97 individual CBOs. To make sure that nothing was lost in the process, there was tracing, bidirectional tracing between the LinX4Rail CBO and the system pillar CBO, so that we could make sure that all the work that had been done by the sector for LinX4Rail was taken over into the system pillar. And based on the, I think it was still a draft version 04, this was handed over into the system pillar and put as an input document in Polarion there now. And this was as well for the architecture group, the reference to relate their work to the common business objectives. So basing on this set of business objectives, the architecture group then went along their methodology and reflected the business objectives in the different interviews, in the use cases they used, and in the pain points, and so that in the spring of this year, finally, there were quite good relations to be made between the results of the architecture work and the common business objectives. What we can see first is that there is a clear and concise definition of the purpose and methodology to how they use the CBO. So the CBO are well reflected in this architecture work done. And most important thing is that the actual identification of the CBO is most easily done on the basis of the pain points identified in the architecture work, and the solutions derived from those pain points that Pierre-Etienne showed a few minutes ago. So the tracing and linking to the CBO was established in the workshop and in the collaboration tool, and was covering the suggested solutions that we heard of. And obviously, this gives a good coverage of regular operation, but are still some open points as the use cases and the resulting pain points are only two, and as Pierre-Etienne said, there's room for additional use cases. Question is, what are the open points in this respect? First of all, the conversion into structured information is necessary quite soon. The common business objectives in the system pillar now are in Polarion as work items. So that's good. So it can be linked to the work items. This has not happened yet. There's no linking between railway system functions of the as-is architecture to the CBO in Polarion. That's work to be done to really then be able to work in a structured way on this topic. And the other question is the coverage. The funny picture on the left-hand side, I deliberately took away the axis. The rows are the railway system functions. The columns are the individual common business objectives as they are stated in the system pillar. And in a very easy world, there would be like one railway system function reflecting one CBO. In a very crazy, complicated world, the table would be covered. And as always, we're living somewhere in between. We see that most of the railway system functions are reflected. We see that most of the CBO are reflected, but there are structural gaps in there. And these structural gaps focus mainly on the fact that the use cases were dealing with regular operation mainly. So we have obvious gaps around life cycle phases in the early life cycle phases in the railway system, like design and of the railway system, adding new lines, authorization to put into market and deployment. We have obvious gaps in operation planning and in prevention and handling of degraded operation. But that's, as I say, that's quite straightforward given the current use cases. So with additional use cases to come, these gaps, I guess, will be easily closed. So that's the common business objectives view on things. If there are any questions, this would be the time. So
thank you, Marcus. No questions? Then, considering the time, we can, I think, thank you. We can give the floor to Jan.
Okay, so I will not repeat quite a lot of what has already been said. I mean, I think in specific answer to one of Thomas' points in the introduction, to ensure that the work that's been done within LinX4Rail-1 and 2 is assimilated and carried on. I mean, I think we can see the three main elements here: the CDM, the architecture, and the CBO. That all of those elements will be a significant and fundamental part of the work of the new joint undertaking. What I want to give a little flavor of, though, is what might be a bit different within the system pillar approach, and also a bit of an overview of some of the elements of the structure and also the process within the JU on the harmonization side, so the route to TSI's standards and other routes to harmonization. So just briefly to give a flavor of the timing, obviously LinX4Rail was running since 2019, and then with the finalization of the Single Basic Act at the end of 2021, the new joint undertaking came into place, and with that there was a short ramp-up project which was essentially working in coordination in parallel with the work in LinX4Rail before the activities proper of the system pillar started in October last year. So chronologically, this just gives a representation of where we are, but also it allows you to see, I think, that essentially, I mean, obviously the content of what's in LinX4Rail is important, but also the principles of the work were important, because I mean it really was I think the idea of the work that's being done in LinX4Rail, the system approach, etc., which led to essentially the restructuring within the joint undertaking of the approach, the split into the innovation pillar and the system pillar, and the fact that this is in now the basic legal act. So as opposed to within Shift4Rail, where LinX4Rail as a project came halfway through the program, we now have the system approach embedded in the basic legal act, in the structure and the governance of the new JU. So beyond the content, it's an important output of the LinX4Rail process that, you know, the ideas have changed the structure of the way that the JU itself is in fact organized and structured. So we've talked in the previous sessions on the activities that have been done in LinX4Rail, how they will be continued either in the system pillar or for the CDM to a large extent within the TT activity. So there are a lot of commonalities of approach between what has been done within LinX4Rail and what we will continue to do within the joint undertaking and within the system pillar. So as has been stressed right from the beginning, it's clearly important, I think, that, you know, well, at least from a European perspective, you know, there are policy requirements, legal requirements to support the development of a single European rail area, both from a market perspective, but also from a technical perspective. And it's not possible to do that without a coherent system view. And also that developments that are happening at a national or regional or local level should be addressed within that overall framework. As Pierre-Etienne said in the last slide, in terms of methodologies, the kind of the approaches in terms of formalized engineering approaches are taken forward and to an extent developed within the system pillar, and the importance in the end of not architecting or modeling for architecting or modeling's sake, but the point is in the end to have benefits for the system. And although Marcus said there was dramatic rewriting of the CBOs, I mean, I would note that, I mean, the intent within the system pillar CBO was not to generate new work, and we essentially relied on the LinX4Rail input and other inputs. And I would say that the material in the system pillar CBOs is probably 85% based on the LinX4Rail material. Those are the similarities. Where do we develop within the system pillar approach? So like I already mentioned in the timeline, there's a difference in the organization and the legal basis now within the joint undertaking. So it is recognized by member states through the ratification of the Single Basic Act that it is important that in the consideration of R&I activities and the development of the rail system, that we don't only support demonstrators, but we also look at the system view in the context of the way that those demonstrators are developed and implemented. So the principles of LinX4Rail are now part of the legal basis of the new JU. On top of that, we have a specific resource and a specific governance for the system pillar processes. This is in part to reflect the fact that the decisions and considerations that we are looking at in terms of the railway system go beyond the strict membership of the joint undertaking. Now, the membership of the new JU is actually bigger and broader than Shift4Rail was. But even so, when we're thinking about considerations of overall system development, the whole sector can and should be involved, and that is part of the governance of the system pillar process. We have, and I suspect this was implemented in LinX4Rail in practice, but it's now formalized that there is, within the working arrangements and the way that the processes are input and developed, are, if you like, done in a balanced way. So the railway and supplier involvement at all elements of the process. Why is this important? It's important because one of the main reasons for putting in place this process when the system pillar was being designed was, and this is when I was in the commission, we were getting a lot of input from suppliers, for example, saying, well, there's this initiative happening over here. There's this initiative happening over here. We have LinX4Rail within the Shift4Rail project. Where is the focus? Where should we allocate our resource in terms of the consideration of the future system? We need one place to be able to do that, and to be able to do that, we need to be involved. So that's on the supplier side. On the railway side, the fact that these initiatives, if you think about RCA or Acora, which are largely railway-led activities, were being in places indicating that there wasn't a total satisfaction with the way that the process was happening previously. So the ask from the sector was to be involved more deeply in, for example, the development of the design of the system and the specifications. I'm thinking largely on the CCS side here. So as a response to that, it has been formalized that there is this shared approach to the development of the system. I think it's important because it kind of binds in the suppliers and the railway into progress. You can't progress on a particular topic without engaging the railways to the suppliers or the suppliers to the railways. Some other issues, and I'll come on to the standardization, harmonization part a bit later. But when we're talking about the embedding of the principles of the system approach, I mean, what does it mean in practice? And we can define an architecture, but in practice, in the end, what it means is the development of products and solutions on the basis of that architecture, but also, again, at a European level, the means to harmonize approaches, either in the TSIs or in standards or other means to support the implementation of those products and solutions at a European level. So not only do you need the architecting work, you need the full thread of activity through to the delivery of standards and specifications. So the coverage of the system pillar work includes the architecture, but also includes the coordination of the outputs on the JU side of the specifications and standards, but also the check back to the architecture. So the full thread of activity is something that goes beyond, I think, what was envisaged in the EU LinX scope. And as part of that, we have within the structure of the system pillar now formalized link to the Commission as chair of the steering group, to the agency as a part of the core group, and to the standardization bodies in terms of their involvement in the various structures. So in terms of this full thread from the architecture to the delivery of the specifications and standards, we also have the involvement of those organizations which will be delivering or developing those elements. So that is important because it means that on, for example, the agency side or the Commission side, when we're looking at what is the expected output from the joint undertaking in terms of where we expect to see, I don't know, improvements in ATO or changes to the CCS TSR or development of standards, this is visible to them early on. So when a standardization request goes out, or when the TSI revisions are being planned, at least from the perspective of what's coming out of the JU, they now have a consolidated view, which actually they will have validated in advance. So this, in theory, should give a more strategic view on the future changes of the system bound into the architecture and system view. A couple of other points, and I mentioned this one previously. There was, I think, a desire, at least from some parts of the overall sector, that there should be a one-stop shop nature to the kind of projects that we're thinking about here. So if we're talking about the development of the onboard CCS or trackside CCS or elements of the TMS, it's extremely useful if it can be agreed that these are consolidated in one place. This is the ambition on the system pillar side. It's not perfect. It won't be fully realized. But for example, we have already seen that EU-LinX is now an integral part of the system pillar process, and will be releasing as part of the first batch of system pillar documents, the next round of the EU-LinX baseline 4 release 2 specifications. So that is also a difference. And then the other element, I think I put harmonization. The part of it is about the link to the outputs in terms of TSIs and standards, but part of it is also about ambition in terms of harmonization. So I very much take on board Thomas' point at the beginning about what is and isn't possible, but it's also the case that at least for certain elements of the system, there is a European policy focus on a harmonized approach. So if we're thinking, for example, on the signaling side, on the LTMS, if there are member states which are looking to convert from Class B systems to ERTMS, of which there are, not all, but many, then is there value as that is being implemented in considering beyond the current ETCS, GSMR for MCS, etc., harmonization approach, a broader harmonization beyond that, if there is that change happening. So the idea is to consider, again, it's something that needs to be discussed and on the table, but when there is change happening, is there the opportunity to have a greater level of harmonization at European level than in the past to support, in the end, the development and delivery of the single European rail area? So in summary, I mean, I think the kernel of the work within LinX4Rail is within the system pillar, but we have now established within the JU program the system view. We have a dedicated governance and resource, and there are considerations in terms of the link between the architecting work and the output, which goes a bit beyond the original concept from LinX4Rail. The following slides are a bit more detail on the system pillar side, which you probably are largely familiar with, so I won't spend lots of time on them, but I just want to emphasize a few things. So the first thing here is within the Basic Legal Act, we have the system approach established. That I think is it's important to note and important to refer back to, because it is a fundamental part of the structuring of the joint undertaking, not an add-on through the program. In terms of the organization, as you will have heard, I think the majority of the LinX4Rail architecting work has been continued to be developed through the task 1, the railway system, and will continue to be developed there. But we also have resource, more resource in the end, in the specific standardization projects. So there are these two elements of work: the overall railway system analysis, and then the thread to the specific standardization and harmonization tasks, with kind of the process of organization by the so-called core group, of which we have some representatives here today: Martin and Judicael and Johannes. Broadly, again, just emphasizing the thread from the overall architecture down to the detailed specification work. In those areas, so the system builder doesn't cover everything in detail, clear. So, I mean, the railway system at task 1 level is at a high level and should cover the whole system, but it isn't looking to, and we don't have the resource to do it, to focus on detailed specifications of all elements of the railway system. So part of the output in the task 1 activities is to identify where there are potential areas of activity for standardization, harmonization activity through the analysis of business and performance improvements, the link to the CBOs, etc. This is a bit of a busy slide, but again, the point is just to emphasize that we have, I think, the 2 elements: the overall high-level railway system analysis, and then the standardization tasks, which at the moment are focused on CCS, on CMS, TMS, and on the DAC. So, and each of these standardization tasks have links to the flagship projects within the JU, and you know, there is should be a coordinated use of resource to ensure that the specification development, the demonstration, the testing, validation, etc., happens in concert. Again, on the standardization activities, there's, in terms of the task 2 in particular, well, no, actually task 2, task 3, task 4, there's quite a high ambition in terms of the outputs for the specific specifications to be produced. This is required by some of the railway sector, and is a major focus for these first few years of activity of the system pillar, that we look to better define European harmonization for elements of the system beyond, on the CCS side, strictly the ETCS track train interface. Beyond the CCS world, and obviously CCS is far from everything, we have the work that was well described earlier on the development of the overall 2B system architecture. And there, as I say, I mean, it's a consideration of the improvements that can and should be made to the overall railway system in terms of business and performance improvements, and consideration of other elements of the overall system. So there is some ongoing work in task 1 on energy. The also important consideration, and this is particularly important, I think, because when the JU was originally scoped, there was quite a heavy emphasis on rail as a central pillar of the multimodal travel experience. But essentially, even though we got a reasonable budget in the end, it was, you know, a third of what we or the sector had asked for. So this element has essentially got less emphasis within the innovation pillar program, but is still an important part, that the outputs of the work that's being done in the flagship projects and the system pillar means that we can improve the way that rail works within the multimodal system, and that means having a consideration of the definition of rail against the other modes. And then, as I say, other potential areas for further harmonization, standardization activity. One area that's a particular focus at the moment is on the diagnostic side. And then this link in terms of the coordination approach on the EU rail standardization and TSI input plan. And what is this? So this is the other end of the process, if you like, so on the output side. So the aim here is that, first of all, there is a collation activity. At the moment within the Shift to Rail process, there was the standardization rolling development plan that gave an overview of the outputs on the standard side. So the main idea now is that we extend this to also include the outputs to the TSIs, which at least on the CCS, the TAP-TAF, OPI, WAG, lock and pass, etc., with the outputs from DAC will be important. So the aim is that the system pillar provides resource to enable all of the potential outputs that will result in specification standards, etc., from the JU activities. They're in one place. It enables the sector to understand what's being produced, not just in terms of demonstrators, but future standardization or regulatory change. But also, another element is, in particular for those areas where there is a standardization focus, and this is largely those areas where we expect input to TSI, there is a quality check and a link back to the overall system view of the outputs of the JU into the various processes, in particular the change control management process of the agency. The view then here is not only to provide a more strategic view and strategic planning of what should be coming out of the joint undertaking, but also ensuring that the quality of output into that process is good and high and mature, so that when it feeds then into the ERA processes, that can be done in a more efficient manner. This is the aim. So, as I say, I've highlighted some elements of similarity, some elements of difference. I've been given a flavour in terms of essentially those areas where we expand a bit beyond the LinX4Rail remit. And I haven't really gone into detail on the subject matter because that would, in the end, take too much time. But obviously happy to take questions, and thanks for your time.
Thank you, Jan. Are there any questions? Or everything must be clear.
Again.
And of course, it's for sure, given also the resource, as you mentioned at the beginning, the limited budget of LinX4Rail and LinX4Rail-2, it was really understandable that the scope is somehow limited to with respect to what is happening in the system pillar, of course. Okay, if we have no questions, maybe we can give the floor now. Thank you, Jan, to Pierre again. For the contributions and continuation to this of the CDM in FP1.
Thank you. So I'm not going to read the summary of the project motional, but it's essentially a project which also incorporates transversal topics, as I mentioned earlier today, and within that transversal topics group, work package 30 in particular is tasked with developing the conceptual data model as inherited from LinX4Rail. So that's why it's relevant to the discussion today. So what does it mean to be transversal in this context? So we have all the other FAs, so FA1 to FA2 to 6, and the system pillar, which have related subjects to the scope of the CDM. So when it comes to the FA2 to 6, what we had worked on during LinX4Rail was the development of a governance process that was, in essence, looking at if there are things missing in the CDM, or do we actually incorporate them? So, as I mentioned earlier, so we have started to have exchange with some of the FAs on specific topics. So I mentioned earlier today the question of yard information, which is currently looked at in FA5, which might have requirements for expansion of around the scope of the TAP PSI, for example. And it so happens that the TAP CSI, we have developed concepts within RSM, the rail system model, that make references to the TAP CSI. So that would be one area of extension. And so we're essentially going to continue discussing with the other FAs to identify potential for expansion as long as we receive input and we iron out the technicalities of exchanging information. On the other side of this slide, there is also interaction with the system pillar. So two aspects. One of them was, so system pillar in particular is working on the MBSE modeling of the system, the railway system. So there are parallel work undertaken, and what we had identified in LinX4Rail was that it would be good to have semantic annotation of the elements of the system in order to make sure that we don't create in the parallel activities redundant components, or rather diverging components, because it's something that can happen when we follow the MBSE methodology. Another one is related to the development of the lexical layer, but I'm going to come back on a separate slide on this. Another key aspects, because we're talking about a conceptual data model with the CDM, is what does Motional do on the data question? So we have things we need to represent, that's the data. We need to represent that data using a vocabulary, and that's essentially what the work package 30 and the CDM is doing, semantics about data. And then another thing that actually emerged as part of the scope of FA1, which was not there in LinX4Rail, is the question of data sharing, data policies, data sharing policies, essentially. And here, so obviously, we'll be leveraging the work that has been undertaken in LinX4Rail around the CDM, but we'll also incorporate a new activity in collaboration with Work Package 31, which is the description about datasets that are being exchanged, and also the policy of exchanging that data. And that triptych between the data, the semantics about data, and the data sharing aspects would essentially offer a good framework for data exchange between parties in the context of the railway system. And just to give some insights about what we're doing at the moment within the Work Package 30. So thanks to Trafikverket effort to provide us a realistic data set, we are actually undertaking efforts around serialization using different streams of approaches. So it's a comprehensive data set of a rail network infrastructure. And so we have essentially three streams at the moment. One, which is to have so it's a proprietary XML format that we are actually providing a Python representation in one stream, and then output project and platform independent representation using RDF. Then there is another approach which actually inspired by the work that took place in a previous Shift2Rail project around the Chimera transformation pipeline, and it's essentially based on the RML language that provides mapping between this proprietary dataset and eventually the project and platform independent representation, knowing that there's also an activity taking place within the system pillar and within task 2 of system pillar, transversal CCS on representation of the infrastructure. So that's the SD1 data model that is under development. And so through RML, we are investigating the transformation of this proprietary XML format into something that would be compliant with the SD1 data schema. And the third stream is ultimately, as I said here, it's more on it's essentially a toolchain inherited from ULinX. Currently, what has been investigated at first on a subset of the dataset is the generation of ULinX data prep XML format, but eventually it could also be done towards the SD1 dataset. So here we are fully utilizing the work that took place in LinX4Rail around investigating serialization. And ultimately, what we also did is to extend the OnToRel knowledge engine to actually incorporate on top of the terminology, so the famous T-box of the ontology. Now we have assertions about data. So here it's what we see on the screen is a representation of the so-called Baltic network in RDF imported into the OnToRel graph database, and then we can link the data to the terminology associated to that data. So here we're giving the example of a switch or a turnout, as it's called in RSM. We also had identified, I mentioned that prior, that we needed to designate unambiguously things in the railway systems, and there's lots of things we need to designate. There are components within the MBSE system architecture. There is data models that are exchanged on interfaces. And there is also the identified need to, for specific use case, to have platform-specific models. And here, in order to maintain, to prevent having multiple CDMs, as per Peter's question earlier, what we had identified is we show provide semantic annotation to make the links between the platform-specific model and the PPM models. And in FP1 Motional, a recent proposal has been made now to formalize the IRI schemes that would be used. The idea being that we'll discuss it a bit more in FP1 Motional, but once it's approved, then we can start implementing it and doing semantic annotation, for example, within the system components of the MBSE architecture, but also in the context of SD1 and its relation to the CDM. And just to make things practical, we have also incorporated, and so we extended the OnToRel knowledge engine interface to now have a convenient way to get the ARI that shall be used to make those annotations in order to actually make it a reality in the future. One additional thing where we inherited in Motional from the work in LinX4Rail is around the addition of a lexical layer. So essentially within the system pillar, but we have also similar question that comes once in a while in Motional. There is a request by the core group to create a glossary of the rail system. Incorporating, for example, the definitions that are done in some of the subsets, but also we have additional sources of vocabulary. And so here, the idea is what we've done in LinX4Rail was essentially focused on the conceptual layer, whereas when it comes to a glossary, people are using terms. Sometimes they are using terms to designate something that is the same term could be used in another domain to designate something else. And where the lexical layer would help is essentially to allow to have domain-specific terminology and to link it to concepts, knowing that if we have that, we can then infer, because all this is machine processable, we can infer that terminology used between domains, for example, would be the same. It would attribute to the same concept, but with a different term. So this is work in progress, but we are essentially here leveraging things that were identified in LinX4Rail on it's too complicated. Lexical ontologies, I would say it this way, like Lemon, for example. Lexicographic, sorry, that's what the term I was looking for. Coming back to this question of inheriting from the work in done in LinX4Rail, so the system architecture is working on identifying functional blocks and interfaces between them. And so what we had identified initially as part of SC3, I think it was called, remember, but is the fact that we could tag with semantic annotation the functional blocks, but also the information elements that are exchanged on the data flows. And there we could do mappings, for example, to a PSM or to the platform and to the concepts themselves. And another consequence it might have is we might discover that we are missing things in the conceptual layers that we will need to add to have a more complete CDM. So that's essentially the idea, which we are building on top of what LinX4Rail investigated. Another thing that we have worked on as well is, so mentioned that the CDM is a federation of models, and as such, each of the constituents of this federation has its own life cycle and its own versioning approach. And one thing we identified initially in LinX4Rail, but which we developed as part of the work in Motional, is an addition to the Ontoren knowledge engine called OntoDiff, which is essentially looking at documenting in an automated manner the changes between source model versions and auto-generating in various formats these changes between versions, and that could be used, for example, to identify impacts on systems that would use a previous version of the CDM of a change of a source model. So essentially, that would help with change management of interfaces, for example. And that's pretty much it. There's lots of things that would come from LinX4Rail, but I think with limitation of time, I'll stop there. Quick.
No, it was. Thank you very much.
Maybe there's questions. Yeah, let's see.
No questions? So it was quite clear then. All right. Anyway, thank you for then keeping really on time, everyone. So now this is time for the conclusion of this morning session. And I will give the floor to Thomas and Christian, and then I will make a very short conclusion for their share on the conclusions of what they have found from today's meeting, and more generally in LinX4Rail.
I will also be very short. First of all, I would to make a broad thank you for all you here and in the team's discussion, all the people who participated to the project, because you've done a very impressive and important work supporting what we discussed today. Thank you also, Jan, for your positive message, and it's very, very glad to see that all what we've done is now integrated in the future for ERGU, and it will be it's not, and I think it's what I will stress as a conclusion today, it's not just results from a project that will be set apart and now another project will begin. It's we've got results which are say usable for the engineering phases of projects, usable for designing, usable for all what's going on into ERGU in terms of harmonization, establish a common platform, a common way of building common things for the European railway. So it's very impressive, very interesting, and thanks for everybody for participating to that. And also it's very happy that we meet here in present. We were discussing with Pierre-Etienne. We had a lot of distant meetings in LinX4Rail, and it's glad at least at the conclusion meeting to discuss physically things, and discussions are very fruitful. Question?
Because Thomas has told everything, I would like to add a warm thank you to Pierre-Etienne. because some sort of final event for LinX4Rail, but I understand that it's one of your last meetings, Pierre-Etienne. So personal thank you and personal congratulations to everybody, and particularly to Pierre-Etienne. Thank you.
Okay. Thank you very much. Thank you all. I think it's architecting work is a collective work, and as it was mentioned, it was we started with the physical meetings, and we were a little bit disrupted by the COVID, and the sessions, distance sessions were. We did our best. I think we didn't realize, this is what I was mentioning during the break. We didn't realize so much that what the difference were. So we did our job. Also, the success was, if I may be quite positive, so such that the system pillar was set up sooner than expected. So at some stage, it was quite also an opportunity, and I think we took this opportunity of feeding the system pillar work, both in the ramp-up phase where we were also in the equivalent of task one, and now with task one. So I'm quite happy that the work is taken with a bigger budget and means. That means that it is valuable for the railway system. And I think we also were in a configuration where from the start in LinX4Rail, the manufacturing industry and railways representatives were balanced in numbers and partners, and that was a very good also sign for success and for collaboration. So I think this is also the way the system pillar is organized, and it's we need a collective contribution to everything. And as it is not completely finished yet, in terms of conclusion, what I would invite you to, for those who can, is to stay this afternoon after lunch for the final architecting workshop from LinX4Rail, but that will pave the way for the next ones in the system pillar task one. So the show continues. Thank you very much, and we can have, I think, now a break for lunch, and we reconvene at around 2 o'clock for the architecture workshop for those who can stay. Thank you very much.